in this topic, we'll be discussing highlighting and annotating our plots. In Matplotlib, we can take some data and we can plot it, and it's so easy and it's fantastic. Have some time series data here, and you can see that it's just a bunch of noise, and then at the end it kind of goes up. But is there anything interesting? Is there anything I should be aware of when I'm working with time series data? Maybe we might expect increases. If this were sales data, I would expect increases in sales around the holidays. How would I go about annotating where the holidays are? And so what we can actually do is we can plot our data as we did above, and then we can iterate over all of the years, the unique years in our data set, and we can actually draw a line from Christmas on every one of those years that spans from 0 to 1, right, on the y-axis. So here our x is Christmas of each year, and our y's will always be 0 and 1. And what I want to emphasize here is that I'm able to do this, and I could label these with text saying Christmas 2015, Christmas 2016, etc. But the trick here is this transform parameter. ax.getXaxis_transform is different from transforms that are attached directly to the axes objects, things like ax.transaxes or fig.transfigure. The ax.getXaxis transform is interesting because it's what's called a blended transformation system. It's blended because our x values, our values on our x list here, or x coordinates, are actually data values, right? This is simply years. It's actually date-time data. Our y values, however, are in the axes proportion system. And so when we use this transform ax.getXaxis transform, we're actually able to specify x values that are in our data coordinate system and use y values that are in our axes proportion coordinate system. And that's all fine and dandy, but if you don't want to worry about transformations or coordinate systems for the most part, Matplotlib does have a convenience around this. You can use the AXV line, and it actually applies this blended transform for you. And so all you need to do is specify all of each point where you want to actually put a vertical line, and you get the same exact output that you saw before, where I manually drew it in with a line, or with using the plotting mechanisms. Now, instead of just drawing a line, what if we wanted to highlight an area? What if there was a certain period of time that was of interest that we wanted to maybe draw attention to? Well, I can see that there is a little bit of a decline from about the start of 2017 to about 3/4 of the way through 2017. I'm referring to right here in January to the 7th. And so what we can actually do is we can take those date times, 2017 of January and 2017 July, I believe, and we can actually draw a rectangle. And I can use Matplotlib to draw things like rectangles, circles, ellipses, lines, because that's all it's doing when you call .plot. It's drawing a bunch of lines. When you call .scatter, it's drawing a bunch of circles. When you call .bar, a bunch of rectangles. And so I can draw a rectangle, and this is going to be a doozy. This goes from x start, the lower left corner of my rectangle is in data coordinates, and then the lower right hand corner on the y-axis is actually in proportion coordinates. And then the width is also in data coordinates, since that's the span of my x-axis here. And so we go from the end date to minus the start date to get that distance, and then we have a height of 1, right, to encompass the entire portion of the axes, and we have to specify this get x-axis transform, so it knows that that 0 and that 1 actually refer to axes proportions. And we just need to actually add the artist onto our set of axes, and there we have highlighted a certain portion of our plot. And just like with the above, there's actually a much easier way to do this using AXVSpan. I just wanted to show you the long way, just so you get an idea for these transforms and these coordinate systems, because they are so useful to know when you want to place things in a specific spot on your plot. And so we can use the AX.VSpan here, and you can see that we end up with a rectangle highlighting certain dates. We can also annotate our plot with actual text and arrows even. And so what you'll see here, I'm going to go back to trigonometric functions. I can draw a sine wave here. And what I want to do, what if I wanted to label the local maximum and the local minimum? Well, I can actually do that with Matplotlib. What I'm doing here is for each extrema, right, I'm using index max and index min here. And so I'm going to get the x position that corresponds to that index max. And then I'll get the y position just by locating right within my data set where that maximum occurs, or minimum in this, both in either case. And then I'm going to use some text formatting to make my actual text I'm going to put, right? So this will say local, and then it'll say either max or min, and then I'll actually give the values of my x and y that I've plugged in. And what I'll do here is I'm using the ax.annotate method. Annotate is a convenience method to get both a text as well as an arrow that points to that text on your plot. And to get the arrow, you need to pass some arrow props. You can put a box around it if you want, but what I want to show you here is that I'm plugging my actual text that you saw me define above. I'm plugging in my x and y position in data coordinates to the location that I want to annotate. Then I'm passing in my text position. And what I'm doing here on the right, you see text coordinates equals axes fraction. Annotate gives us just a convenient way of specifying what my text coordinates are, what that transform is, right? And so instead of passing transform equals ax dot trans axes, I can actually just pass in a string specifying that my text is in axes fraction coordinates or axes proportion coordinates, and my actual label that I'm annotating is in data coordinates. And what we end up here is I'm able to actually annotate where the local max and the local minimum are very easily, very readily. And the best part is this is programmatic. Whew. And so if I were to have multiple mins and maxes, I could set up my function here, or my script here, such that I can label every single one of them. I can just label some of them, and it just allows me to easily envision what the values are at each of these points without having to worry about, going through my data, finding each one, and then having maybe to print it to screen instead of putting it actually on my visualization that I'm going to share. Another way that we can annotate or give some meaning to our data is by using colors. And you've seen me plot many things where the colors just automatically change, and I want to give you just a little bit more control over the things that Matplotlib does for us and give it back to you, the user. And so what we can do here is we can actually pass a color parameter into our .plot or .bar, etc. methods, and this will actually make our plots these colors. I'm using this getCmap function. Matplotlib has a lot of what we call qualitative color maps, and those are the colors that you see. It iterates through, it's kind of like a categorical color map. So each color is very different from the one before it, such that you can very readily highlight unique groups within a data set. And so when I do this, I actually end up with the same thing that you've been seeing, that nice blue and nice orange. Now, I can also pass names of colors, red and green. These colors are a little harsh. They're very visually vibrant and strong. And so that's why Matplotlib likes to use the default of that tab 10 color palette. You can also specify colors manually by annotating what qualitative color palette you want it to come from. So in this case, I'm reaching into that tab 10 color map, and I'm getting the blue color out. And then I'm reaching the tab 10, I'll get the orange. And just to make this a little bit more interesting, I'll make this red because we've seen the orange before. And so when I do this, we actually see that I get red and blue lines instead of red and orange. But how does Matplotlib manage all of this, right? How does it know that tab 10 is the default, and then every time I call .plot or whatever, .bar, it knows to advance to the next color? It uses what are called cyclers, what it refers to as cyclers. And so you can actually see here that I can instantiate an axis, and then I can set my cycler, my property cycle, right, to this cycler. And all this cycler will do is iterate through all of these colors. So I'm getting the colors out of my set1 color map. This is different than the one that tab 10. And I'm going to cycle through them, and I'm going to tell this axis, hey, every time I plot on you, advance the cycler to the next color in my set1 qualitative color palette. When I do that, you see I end up with blue then red, as is the set1 color map. I can also set it to tab 10. This is explicitly because tab 10 is the default in Matplotlib. But you can see I can set it to tab 10 explicitly in this axis. Whenever I draw on it, we'll use the tab 10 color palette. I can also manually specify different colors. So I could plug in red and blue in here, red and green. But what's very cool about the cycler objects is that you can actually add them together. So I can say cycle through these colors and at the same time cycle through these line styles. It's kind of like zipping them together in a way. And it will actually pass this color and this line style to each time I plot in Matplotlib using that ax.plot method. Now it's really important to note that this cycler is attached to this axis object. So if I were to create a new axis and then start plotting on it, Matplotlib would reach back in, use its default values. You can set these things in Matplotlib's RC params, but I'll leave that to you to find because it is just a little bit outside of what I want to talk about here with how you can control the specifics of Matplotlib. And so, when you're choosing a color palette, I would always encourage you to think about your data and what color is meaningful. Matplotlib, for things like heat maps and really any images, has a default color palette that I'm not too keen on. This goes from a dark blue into a green, then into a yellow. And that's actually decently okay for a heat map, but if you've ever plotted in MATLAB and it uses that jet default color, it's almost impossible to make heads or tails of the data. What you want for a heat map or a correlation map specifically is you want a color palette that diverges. So around 0, you get some very neutral color, and then +1, you get a dark shade of one color, and then -1, you get a dark shade of another color. Also, note that here my color bar only goes from -6 to +1. If this was a true correlation map, which it is because I correlated myself, this should go from -1 to 1. If I were to look at this heat map, this correlation map here, and I were to look at the correlation between these two, the errors between an exponential and a standard normal distribution, I would say, oh, they're almost perfectly anti-correlated. Wrong, because my darkest shade of blue only goes to 0.6. And so when you work with colors in Matplotlib, you should always be thinking about what space should my colors occupy, right? Using this Vmin and Vmax. And then also, what color map do I want to be using? What color map actually conveys meaningful information about the data? And so here you'll see that I'm using this red-blue color map. And you'll notice that now all of my negative values are blue, all of my positive values are red. I could flip that if I wanted to, and any weak correlation or near zero correlation is going to be some shade of white or off-white. But I'm using the red color to annotate that, hey, these are positively correlated, and I'm using any shade of blue to annotate that these values are negatively correlated. And so you can use colors to really apply some meaning to your data. Next, to highlight a specific portion of a plot, I want to show you this regression plot. And so when I plot a given regression, right, I get, scatter points and I get a nice regression line that I calculated and then plotted myself. But what this fails to convey is the certainty, right? Where's the uncertainty, I should say, statistically speaking, where's the uncertainty in my slope, right? This regression can't be perfect because not every single point lies on it. How do I convey uncertainty within a visualization? Well, you can actually use fill between as a method to highlight specific patches or specific areas. And this is distinct from things like V-lines and V-spans, or H-lines and H-spans. What I'm actually able to do here is encompass values that I actually haven't seen, right, that just span from my X min to my X max, and then I can factor in, right, my regression, the standard error from my regression slope, and the standard error from my regression slope in a positive manner, such that I fill in an area that's encompassed between my mean slope plus or minus my standard error. And you'll see that I've just completely overridden my data and all the scatter points are gone, and it's not pretty yet. What we do here typically with these things is apply an alpha. So we dull down the opacity so it's not just a fully non-transparent color. And then I can actually force this color of the filled in area to be the exact same as the line. And we end up with actually a nice filled in between area between that encompasses most of my data, but not all of it, because this is the uncertainty within my model. And you can actually see here that my regression line does a really good job at predicting data. And so we wouldn't expect many outliers if we were predicting unseen data in this case. And that is how you can annotate your plots. You can add colors. You can convey meaning into things that need context. That's how you make it pretty.